Hello, ladies and gentlemen. All right. So we are looking at conic sections today. Moving my picture where I think it'll be all the way. There we go. So this is conic sections, and conic sections are pretty interesting. I used to, years ago, and we're talking years ago, I used to teach conic sections in Algebra 2. It has since been removed from the standards, even though it's very, very cool. So conic sections are literally formed from cones. And so you can imagine these, it turns out that there's two cones. And these are solid figures, okay? Sorry, it's a really bad drawing. But we've got these two cones, and they're inverted on top of one another, point to point. And what happens is, depending on how you slice those cones, they create different shapes, and those are called conic sections. So when you take a section of something, like a cross section, so imagine if I were to take these cones, which are, straight up and down this way, it's these cones, and if I were to just slice it right parallel to the ground through there, and then you take apart those pieces and look at it, well, the section we would see would be a circle. So if I were to slice that cone right through there and look at that piece, when you turn it and look at it, it's the shape of a circle. Well, if I were to take those cones and slice at an angle, slanty-like, all right, and you slice through those three-dimensional cones and you take it apart and you look at the section, the cross section, that would be kind of a stretched out circle called an ellipse. And so if you were to cut vertically, those would be called parabolas, all right? So very, very cool. And those are conic sections. And so we're going to talk about a few of them. There's actually also hyperbolas that are conic sections as well. But I mainly need you to know about circles. We're also going to work with ellipses just because it's kind of a neat change that happens to this standard form. So here we have conic sections. We're talking about circles today. This is the standard form of an equation of a circle. Now, on the first day, the first lesson, 0.1, I told you about the basic form, x squared plus y squared equals r squared. Well, the only change here is that we've added the h and the k. And of course, we've seen lots and lots of formulas with h's and k's, and the h and the k are just the horizontal and vertical shifting that happens. So if it's just x squared and y squared, we know that the h and the k were 0. Beyond that, it's just translating and sliding that center point up, down, left, and right. So hk, you'll notice this is the positive value of h, and the positive value of k is the center of the circle. R is the radius. R-A-D-I-U-S, all right, is the radius of the circle. And so for this one, it's just centered at 0, 0. Any other numbers in there, it's going to be shifted left, right, up, and down. You can use your calculator to graph conic sections. If you have a TI, then it's in the apps program. You can see there's a conics menu there, and I bet you can figure out how to use that. It's pretty easy. So I wanted to show that. Also, if you have the Casio, then you would go to menu. So if you're new to Casio, the menu is menu driven. So they use the F1 through F6 buttons a lot. They use the menu. You can see you have a menu straight for conics. You have a graphing menu that we use a lot. And so in the conics menu, again, you can see it's pretty well done. There's lots of different formulas they have for you. That's ellipses. We'll see soon. This is the standard form of a circle right here. So it's really easy. And I bet you can probably figure that out too, but it's all there. And also, if you're using this in this calculated option button is really good to know, and exit is really good to know. So keep that in mind. But I bet you can figure out those conic sections menus. today for your practice, you have this assignment in Delta Math. Hopefully that's going well for you. And again, get it done as soon as possible, hopefully today. The goal is always the day that it's listed is the day it should be done. But if you run out of time or have to get to work today, I understand. We all have things to do. We're all multitasking these days. So, it's at the very latest by Sunday. And of course, that's every assignment during the week is hopefully due on the day that I assign it, which is the day that it is in the calendar. But, if you can't get it done, pick it up later, pick it up the next day. That's fine. Finish it the next day. But definitely by Sunday. Okay. And that's, by the way, 11:59 p.m. So right before midnight, I want you to get to bed. My dad never used to, when I was in high school, never used to let me stay up every single night. Here I was in calculus, trying to learn my calculus, and every single night at 9:30, he'd knock on my door and say, Amanda, it's time for bed. And I'd be like, but I'm working on my calculus. And he says, I don't care, go to bed. And he would come back at 10 o'clock and make sure I was in bed. You should be in bed too. All right, at 10, not right now, by 10 o'clock. Okay, example 1, graph the circle. And of course, we're not looking for beautiful pictures here. That's not the point. But the point is that we understand how we work the formula and then a basic understanding of how to get this standard form equation. We love standard form. You can see we've got some changes in X and changes in Y happening. X direction is being shifted to the right 3. So this has a center right 3 units. And here we're changing in the Y direction. That's actually going to go down 2. So remember, everything is sort of opposite. So keep that in mind in the HK form here, like this. It's opposite. All right, and then our radius, now this is 9 is the radius squared. So our radius would be 3. And so all we have to do is go to the center at 3, -2. And then we can count our radius. 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 to the left, and 1, 2, 3 down. And there is our circle. That's it. So when it's in standard form, graphing a circle is super easy to do. Let's look at letter B here. Again, we're in standard form. And so this has a center. This is being shifted left 1, so -1, and that's going to be up 3 in the Y direction. So again, opposites. And this, r squared is equal to 8. And so we would have the square root of 8. Well, I don't know exactly what the square root of 8 is. I could try and remember how to simplify that, but it's not very important. I could use my trusty rusty calculator if I wanted to and think, well, the square root of 8 is 2.82. Well, that's great. What if I couldn't have my calculator? So in calculus, you really don't get to use your calculator a ton. And when you use it, you're really going to need it. So keep that in mind. If you don't really need your calculator, you don't really want to use it. The square root of 8 is less than the square root of 9. It's greater than the square root of 7, which is greater than the square root of 6, which is greater than the square root of 5, which is greater than the square root of 4. Okay, well, that was a whole lot of work. I don't care about any of this. I wanted to write it down, though, because you can see that we know the square root of 4 is 2. We know the square root of 9 is 3. And so it's pretty clear that the square root of 8 is going to be a little bit smaller than the square root of 9, which is 3. In fact, it's much, much closer to the square root of 9 than it is to the square root of 4. We had all these other things in between, not to mention an infinite number of other numbers. So keep that in mind. We just need to approximate. We're just graphing by hand. So -1, 3 is the center. And this is a little bit less than 3 in length. So I'm going to go 1, 2, not quite 3 to the right, 1, 2, not quite 3 up, 1, 2, not quite 3 to the left, and 1, 2, not quite 3 down. So, and that's it. It's fine. That's perfect. I think on the Delta Math has a really cool drawing tool, I believe, if I remember right. It was a while ago when I did this stuff, guys. So I think it has a pretty neat drawing tool. So have fun with that. All right, this is the part you really want to know. We want to write these general form equations in standard form. So general form just means that there aren't any parentheses, there's no grouping symbols, everything's been stretched out and multiplied. So we want to put it back into standard form. And in order to do that, it's going to require completing the square. And we would have done this last year, but of course we didn't get a fourth quarter. So complete the square. We've done this before, ladies and gentlemen. We need to complete the square. And in order to get us going, the first thing we want to do is collect all our like terms. And I also want to think about getting it into standard form. The radius is on the right-hand side. And so anything that looks like a number that could just be a radius, I want to go ahead and move that to the right-hand side. I'm going to go ahead and take my x terms and rearrange those. So I have x squared plus 14x plus a blank. And then I want to take my y terms. So positive y squared minus 12y plus a blank equals, I moved my 4, so it's going to become negative. And remember, if I'm going to add values to complete the square on the left, then I also have to add values to complete the square on the right. And I hope I don't run out of room. So I have a blank space for this blank to keep the equation balanced, and I need a green blank as well. So that is really a big point. Remember, you have to keep your equation balanced. So what value goes in here? I don't know if you remember. That is the secret complete the square, the C value. That C value is whatever this B is divided by 2 squared. All right. So in this first one here, I'm going to take this 14. We're going to divide it by 2. That gives me 7. Square it, we get 49. We're going to take this negative 12 here. We're going to divide it by 2. That's negative 6. And we're going to square that. We get 36. We add 36 to both sides. All right. Once you've added in those very, very special C values, and again, it's there, right? All right, then what we've done is we've created a trinomial that factors perfectly. We can double bubble. This double bubbles as x plus 7 times x plus 7, or simply go right to x plus 7 squared. In green here, and that plus sign in the middle, again, we have this wonderful trinomial that's the special 36 there that creates this really great thing. Y minus 6 times y minus 6 gives us that trinomial when we factor it, or it's just y minus 6 quantity squared. And then I'm going to use my calculator because these numbers are way too big for me to add in my head. Negative 4 plus 49 plus 36. And this is certainly something like I over the summer had to take a class for AP Calc, and we get to look at like student AP tests and the work, and this sort of stuff you don't have to do on the AP test on the short answer. And the problem is that you can just leave this gobbledygook just like this. It's accurate. It's not incorrect. But the minute you add wrong and say 80, now you lost a point. They can't give you credit for that because 80 is not correct. But if you had just left it negative 4 plus 49 plus 36, it was right. It wasn't incorrect. And that's the key. And that's what you always need to be thinking about. Don't do more work than is absolutely necessary. And we're going to talk about this all semester long. That's it, ladies and gentlemen. It's in standard form. The center is negative 7, positive 6, and the radius is 9. All right, so this is standard form. This is all they were looking for. This is great practice for completing the square. Again, also a skill that you're going to have to remember later on. So I just wanted to put it out there so that you were forced to remember it. I'm going to draw a line because my work got a little bit crazy, Jones. All right. So again, just one more for practice here. I'm going to take my negative 55 and move it to the other side. And I want to go ahead and combine put some like things together. So I have my x squared and my 2x. I'm going to work down here. X squared plus 2x plus a blank. I have my y squared and my negative 10 y. So plus a y squared and a minus 10y plus a blank. Now I'm moving my 55 over, so it's going to become positive 55. And I'm running out of a little bit of space here, but I'm going to go ahead and add a blank for my purple blank. And I'm going to add a green blank there. Sorry, it's squishy. All right, so what goes in those blank spaces? Again, b divided by 2. So 2 divided by 2 is 1. Squared is 1. 1. Negative 10 divided by 2 is negative 5. Squared is 25. All right. Hopefully this is familiar. You remember doing this once upon a time. It might feel like a long time ago. All right. X squared plus 2x plus 1 does double bubble. If you need to double bubble, that's a great step to do, but it isn't necessary. X plus 1 quantity squared is how that double bubbles. And then again, you can double bubble this. It works perfectly. X or y minus 5 and y minus 5. Y minus 5 quantity squared. And again, I don't even want a chance getting this wrong. 81. Again, hey, that's a coincidence. All these three things added together is 81. All right. So again, this is the form that they were looking for. Standard form is always awesome for graphing. So again, this would have a center at -1, +5, and a radius of 9. So keep that in mind. Standard form is really, really good. All right, just a little bit more here. Example 3, write the standard form equation of the circle. So they're giving us details about a circle, and we need to figure out an equation for it. This is really good stuff. So I want to, when in doubt, graph it out. I don't have an idea of what this looks like. All I know is that it's a circle, and it has a little bit of information. I can make a sketch. So don't be afraid to make drawings. I know I took a half dozen AP Calc tests this summer, and I was making little sketches like this all over the place. So 2, 1, 2, 3, 4, 5. So here's the center at 2, -5, and then 1, 2, 3, 4, 5, 6, 7, -7, -1 right here is a point on the rim of the circle. So this is the center, and this is a circle that is going around it like this, okay? It's really important to have an idea of what's going on in the picture. You know, just giving yourself numbers, it's not super helpful. So what I have then, if this is a point on the edge of the circle, on the rim, all right, then I have a radius here. And I can do a lot of different things. One of the things that I can do is the distance formula. But I also happen to hate the distance formula because it's really just a more complicated Pythagorean theorem. So because I drew a picture, I'm just going to count. I'm going to create a triangle. Let's see here. I have another color. So I'm going to create a right triangle, and this radius is just the hypotenuse of that right triangle. So let's see if I can draw that -5. This is this horizontal line. All right, this horizontal line starts here at 2 and is going in this direction all the way to -7. So how long is that horizontal line? It's 9 units long, isn't it? Yeah, that wasn't hard, was it? Okay. And then we're going to go vertically to this point. Well, it's starting here at -5, and it's ending here right at this point at -1. So what is this vertical distance? 4. Yeah, that wasn't hard either. Okay. Well, it turns out then, if we know that much, then a squared plus b squared equals our radius squared, right? Leg squared plus leg squared equals hypotenuse squared. And that's certainly the easiest way to figure this out. 16 plus 81 is 97. Oh, that's a horrible answer, but we're going to go with it. So radical 97 is our radius, but that's fine. I know my standard form model, x minus h quantity squared plus y minus k quantity squared equals the radius squared. And I happen to know that my center is the h value and the k value. So I have x minus 2 quantity squared plus y minus a negative 5. Minus a negative 5 becomes plus 5. And then r squared, well, r squared is right here. It's 97. All right. So there's our model. I hope I did that math right. I think I did. Looks good. An ugly number, but it works. Okay, so again, same idea with letter B. Here they're just giving us the endpoints of a diameter. So this one is very interesting. Again, I want to draw a picture. So I'm going to make a wee little sketch. It's pretty ugly here, but I'm going to go ahead and do this. Let's see, 1, 2, 3, 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. There it is. Negative 3, 11. Then we have 3, negative 13. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 3, negative 13. This is not useless work, ladies and gentlemen. When I taught geometry, I didn't give them credit if they didn't have a picture. Okay, ladies and gentlemen, this is a diameter. So between these things, look at me with my straight edge right here. I must be a math teacher. Oh, and look at this. You guys remember this? Oh, bringing out the jam jar lid. Okay. Hey, that's pretty damn good. Look at that. So you can imagine there's this circle that is connecting those diameter like this ish. Sort of. All right. So this is a diameter. Now, what do we know about the diameter of a circle? It passes through the center. It passes through the center of the circle. It must. It always passes through the center of the circle. It's also twice the length of the radius. So there's so many different ways that we could solve this problem, but we do need to know the center of the circle. And that center is going to happen at the midpoint. So the midpoint is the average of the x's and the average of the y's. So negative 3 plus 3 over 2. That'd be how we calculate an average. Add and divide by the number of entries. All right, and then add the y values. So 11 plus a negative 13 divided by 2. All right, so this is our center, which is going to be 0, and that's a negative 2 over 2, negative 1. Hey, look at that. It's just a picture, but it's pretty good. Not too bad. It's just a crappy drawing, but I believe that this is my h and k values. So that's really, really good. I can use that if I know that it's at 0, negative 1. I'm going to go ahead and use that because I can then see that this now is my radius. And I could use this part or I could use this part. They should be identical. In fact, that'd be a great way to double check that you did it right. I'm going to do the same thing here. I'm here at 3. I'm going to go horizontally. And then to do that, I'd have to go 3 units horizontally back to 0. And then how many units vertically? We're going from negative 13 to negative 1. That's 12 units vertically. And so we can do 3 squared plus 12 squared equals our radius squared. 9 plus 144, which would be 153. I'm just going to leave it like that. I don't need r. I actually need r squared in my model. So x minus h, that's going to be x minus 0, quantity squared, right there, plus y minus a negative 1 becomes plus 1, equals my radius squared, which is going to be 153. I hope that's right. If it's not, it's going to be close to that. Okay. Hopefully that's good. So again, draw a picture. When in doubt, graph it out. Make a sketch, because there's a lot of information from those pictures. And again, this was just one way to do this problem. I can think of 5 others off the top of my head that I could have done. So Lots of ways to think about these things. But I think it's really nice to know that the Pythagorean theorem, I love the Pythagorean theorem. So much comes from the Pythagorean theorem, and we're going to use the Pythagorean theorem so much this year. The distance formula is annoying, and it's just the Pythagorean theorem without all the mess. So if you've got a picture and can count, it's totally fine. All right. Thanks, guys. Hopefully that was fun for you. As fun for you as it was fun for me. All right. Have a great day.